Today we're going to review a couple of different variations on generating linear regressions and linear regression statistics in Excel. First of all, let's go open Excel and we'll get the spreadsheet we used previously for protein concentration assays. We'll get rid of all of the sample data. We're just interested in the standard curve. We can use Excel commands to generate the parameters of a linear regression, the slope, the intercept, the R-squared value. Now, so I've just entered those as categories here. But first, let's just make a quick chart. Scatter plot, there it is. You know that I like to, well, we can certainly add a trend line. We're familiar with that. We're not going to do that today. We don't care about that. We're using our intentional tools for generating our own regression analyses. So we'll just use the formula entry here to say equals slope, and we'll highlight the known y values as you're prompted for, and we'll highlight the known x values and then close the parentheses and hit return. And we'll do the same thing for the intercept. Again, notice that you are being prompted for the known y's. And you can enter those manually, B2 colon B10. In this case, we'll gather all of those data, or you can select, of course. Finally, we'll compute the R-squared for this correlation. Remembering that R-squared, oh, and thank you, Wikipedia, is a measure of how the regression compares to the average of all of the data. So if the regression is better than the average errors, then we should get a regression R-squared of something very close to 1, which we do. So the next thing I want to do is to go and generate the line that represents those fitted parameters, the slope, the intercept, and we can do that by creating a new column called fit. And I'm giving it absolute references here, right? So $B, $squared, $12, that's going to give us the slope times the x values. Notice that the x values are in a different column than our parameters. We enter all of those parameters, y equals mx plus b, and autofill down, and we get data for not only for the absorbance now, but also for the fit. So let's regenerate that data chart. This time I'll choose a line with markers, and I'll drag the cursor over to collect both the absorbances and the fits to those. And we can modify various things. Of course, there's no reason to have our axes go to 2500. We'll go to 2000. We'll right click on the regression to change things around so that we can get rid of those markers, which we don't want. So we go to marker options, choose no markers, and then of course let's change our line color to something much more presentable. Likewise with the data, we don't need to interpolate the data, so we can go back to format the data series and color the markers black, yes, and get rid of the line. Sometimes you have to make sure that you change the fill as well as the border if you choose a border around your marker. Yes, notice that we have not selected that sort of standard chart type. You can always go back to design. But first, let's create some residuals. So we've made a nice linear regression ourselves. If we create a column called residuals, that's just going to be the data minus the fit to the data. So in this case, B2 minus C2, we'll fill that down. And now we have another chart that we can generate that represents how well our model fit the data. So here we can go back to design, reset that, yes, get rid of things that are extraneous. But now let's go make a new chart. Scatter plot of the residuals. And yes, choose your layout. You can't see anything yet because why? I haven't selected any data. So right click to select some data, add a new series, call it residuals, and select the X data and select the Y values. in this case the residuals in column D. And okay. So now we have a residuals plot as well as our regression. So we see our regression, but now we can see if there's some systematic way that the data are deviating from the model. That's very important in doing curve fitting. But first, let's go back and adjust our figure, get rid of certain things like those grid lines. You know, I want things to be consistent, so we're going to make those nice black markers. Oh, but look, our x-axis labels are in the wrong place. So we can right-click on the x-axis, set it to 2000, of course, but we also don't like the position. Oh yeah, there's still problems with the border, blah, 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 all those little details, niggling details. I don't like the position of that axis, so I can right-click on that and choose to format the axis. And one of my options under labels is to choose whether I want it above or below or inside the graph. So we're going to choose below the graph, traditional. And now you can see how the residuals deviate, how the data deviate from the model. It can be very, very useful to determine if there's some kind of systematic error source in your observations, or that your model is just not the appropriate model. Now, we can also go to the data analysis add-in to play around some more with regression tools. And we did this a little bit last week. We'll remind ourselves how this works again. We just choose the regression option for our data analysis tools. We'll select our Y values appropriately. That is your absorbances from your concentration assay and your concentrations of your standards. Choose the various options. Let's generate residual plot this time just to compare with the one we generated. And we'll choose 95% confidence intervals, although we won't use it today. And we just say okay, and we see that we get a new sheet pop up, a new ply in our spreadsheet. We can right-click on that name and call it regression analysis. And we see that we get a plethora of information, including, yes, the kind of plots that we just generated, including the residual plot. So we get the standard regression statistics output. Really, the only one that's relevant to us today is R squared. Multiple R is not so relevant for such a simple regression as we've done today. You also see that you get some ANOVA or analysis of variance outputs. Doesn't come into play in our discussion today. Finally, let's look at one more way of carrying out linear regression or analysis of linear regression. And this involves the creation of an array function called lineest. So you see that I've clicked and dragged over a 2x3 array, and then I enter in the formula entry equals lineest, and I give it my y and x values, and then followed by two options. You can see that those are having to do with the various parameters of the regression analysis, and we'll set those can either be true or false, or 1 or 0. In this case, they're both true. So again, lineest is an array function. That it means it's going to act over all of those data. You have to use the Control-Shift-Enter, and then you'll see brackets appear around the formula entry as well. And now we see that we got a bunch of numbers. Those should look familiar. Down here, I'll enter the fact that those are the slope in A17 and the intercept in B17, as well as the standard deviation for both the slope and the intercept. And of course, we'll get our squared value and our standard error value. So there's a whole wide range of generating linear regression data without resorting simply to the trend line.